Okay, this is the video answer sheet for the speed acceleration equation retake um, paper that you have to do in order to be able to retake this section of the test. So you're going to correct your worksheet, checking for all of the required elements to solve a problem as I go through this. If you have anything wrong, fix it as we go. So in this first problem here, it's asking you to solve for speed of a jet plane that travels a distance of 756 meters in 10.5 seconds. So again, we always start out by putting down our equation. Speed equals distance divided by time. The distance was 756 meters. The time was 10.5 seconds. When we run that through our calculator, we get 72 meters per second. And again, always put a box around your answer. On problem 2, it says how many seconds will it take for a satellite to travel 456 kilometers at a rate of 120 meters per second. So the problem is asking us to solve for time. Time is equal to distance divided by speed. Now here's going to be some problems in here. The distance is 456 kilometers, but the speed is 120 meters per second. So the problem we have here is we've got mixed units of distance, kilometers and meters. So what we have to do is we have to change either kilometers or meters. I'm going to do it by changing meters into kilometers down here. And I know that there's 1,000 meters for every 1 kilometer. And then my units of meters will cancel. And when I divide this out, 120 divided by 1,000, that comes out to be 0.12 kilometers per second for my speed. So I just changed 120 meters per second into kilometers per second. So now I can work the rest of this equation. Time is equal to distance over speed. So the distance still is 450 kilometers. The speed now is 0.12 kilometers per second. Now my kilometers divide away. The second's going to move up, so that's going to come up. So 450 divided by 0.12 is 3,750 seconds, because the seconds moved up. In this problem number 3, it says how far in meters will you travel in 48 seconds running at a rate of 6 meters per second. Now the rate here is speed. That's what they're talking about. And you could probably recognize that by the units that the problem has. So in number 3, we're going to be solving for distance. How far means distance. So distance is equal to speed times time. The speed is 6 meters per second times a time of 48 seconds. Time units cancel out those seconds. So 6 times 48 would be 288 meters per second. We'll put a box around it. On number 4, it says, how long, keyword, will your trip take in hours if you travel 489 kilometers at an average speed of 75 kilometers per hour? So we're solving for time. How long is time? Because it gives you a hint here, hours. So time is equal to distance divided by speed. The distance is 489 kilometers divided by a speed of 75 kilometers per hour. Now the kilometers divide away. Our hour is actually going to move up. It's going to come up here. So 489 divided by 75 would be 6.52. It's 52 hours. On number 5, it says, what is the speed of a jet plane? So we're solving for speed. Speed is equal to distance divided by time. The distance is 758 meters divided by the time of 14 seconds. 758 divided by 14 would be 54.14 meters per second speed. On number 6, it says a skateboarder traveling at 7 meters per second rolls to a stop at the top of a ramp in 3 seconds. What is the skateboarder's acceleration? So from our equation card, we know that acceleration is equal to the final velocity minus the initial velocity divided by the time. So final velocity is always the last recorded speed. So the last speed here, because you've got to look at this, it says they're traveling at 7 meters per second, rolls to a stop at the top of the ramp. That means his speed went to 0. His last recorded speed was 0 meters per second minus 7 meters per second, because that's the first recorded speed, which is initial velocity, divided by the time that it takes to do that. That was 3 seconds. So 0 minus 7 is going to be a negative, divided by 3 would be 2.33, and the units are meters per second and then squared. Now we can have a negative answer here. That is called deceleration. Deceleration simply means that they slowed down. And it did, because if you read the problem, it said that it came to a complete stop. So it means it slowed. So in this problem, it says a car starting from rest accelerates at a rate of 8 meters per second. Now, the second is the same as saying second squared. What is the final speed at the end of 4 seconds? So we're solving for final velocity. VF is equal to time times acceleration plus the initial velocity. So here we have a time of 4 seconds times the acceleration of 8 meters per second squared, you can say it that way, plus the initial velocity. Well, the beginning speed, what is the beginning speed? It said it started from rest. That means it was going at 0 meters per second. So 8 times 4, this second's going to cancel with that one. So 8 times 4 would be, 32. Units are meters per second, plus 0 meters per second would give me an answer of 32 meters per second. Number 8, it says, as she climbs a hill, a cyclist slows from 25 meters per second to 6 meters per second in 10 seconds. What is her deceleration? Well, deceleration is still the same as acceleration. So we're going to use the acceleration equation. Acceleration is equal to final velocity minus the initial velocity divided by time. So the final velocity is always the last recorded speed. So it slows down from 25 to 6. So 6 meters per second is the last recorded speed. 25 would be the beginning or initial velocity. Okay. And the time that it took her to change was 10 seconds. So 6 minus 25 is going to be a negative, divided by 10 comes out to be 1.9 meters per second squared. And again, since it's deceleration, it's showing us that she is slowing down. Anytime you have deceleration, you're going to get a negative answer. And that tells me simply that they slowed down. On number 9, it says that a car traveling at a speed of 30 meters per second encounters an emergency and comes to a complete stop. Hint. Okay? How much time will it take the car to stop if it decelerates at a negative 4.0 meters per second squared? So we're again, how much time is what we're solving for. So time is equal to the final velocity minus the initial velocity divided by acceleration. So final velocity is the last recorded speed. So it comes to, it says it's starting at 30 meters per second, but it stops. So that would be 0 meters per second minus the first, which is 30 meters per second. Because when you come to a complete stop, you're going 0 divided by the acceleration, which happens to be minus 4.0 meters per second squared. So 0 minus 30 would give me minus 30 meters per second divided by a minus 4 meters per second squared. Meters cancel, one of the seconds cancel, this other second comes up because we're measuring time. A negative 30 minus a negative 4 is going to be equal to 75, and the units are seconds. And then the last problem here, it says a helicopter increases speed from 25 meters per second to 60 meters per second in 5 seconds. What is the acceleration? Again, so we're solving for acceleration. Our equation is acceleration is final velocity minus initial velocity divided by time. So the last recorded speed is the final, that would be 60 meters per second minus the initial, 25 meters per second divided by the time of 5 seconds. So when I run this through my calculator, 60 minus 25 divided by 5, I come up with 7. My units are meters per second squared. And that concludes this. So you need to verify that you've corrected this by showing me your corrected worksheet, and I'll check it off. And then if you have all the other requirements for retaking the equation part, you'll be free to schedule a time to come in and make up that section of the test.